Hey everyone, welcome to another video on Blender Geometry Nodes. In this video, we will see about sample curve node. I release new videos on a weekly basis. Please subscribe to my channel so that you will be notified when I upload a new video. This is Jay from CJ Academy. Let's start. Okay, I have my own custom workspace setup. I'll share the link in the description how to set it up. You can take a look. In this video, we are going to see about curve sample curve node. So if you see, it takes a geometry input but doesn't give a geometry output. That means this curve output should be used in another geometry context. First, let's see what this sample curve node has. That let's bring in a spiral node, curve spiral, and connect it. Take this to the output. Still need the geometry output. If you see the spreadsheet editor, the viewer has all 0 because the value output takes the input value of this one. So value here is actually for any of the custom attribute you have. Okay, so any of the attribute values, if you want to store, you can store here and take it out here. So in this case, we don't have any attribute connected, so let's disconnect this and connect the position value here. And you can see this has a data in it, and this data is actually based on the factor value. If you remember, in spline parameter node we have used the factor value from 0 to 1. Okay, so based on that, here also the length value or the position value changes. Okay, same way as tangent. Okay, tangent value also changes based on the factor value, and same as for normal. Normal means the upward direction value. Tangent means the tangential direction value. Okay, and what is length? Length also same thing, but it just controls based on the length factor. Okay, you can see the difference. Same way for position, it affects the same way as the factor, but this is calculated based on the spline length instead of the factor from 0 to 1. Okay, same as normal, tangent, and everything. Now this is on the theoretical part. Now let's see one example, like propagating a geometry along this curve. Okay, for that, let's bring in a mesh geometry. Now that's the cone, and connect this to the viewer. To view it along with the curve, let's bring in the join geometry node and connect the curve also, and change the set position value for the cone. Okay, so we are taking the spiral position value data and affecting the offset value of the cone, and then seeing it together with both the curve and mesh geometry. Let's change this value a bit. Now if you see, the offset value is not controlled based on any input from this spiral. Let's bring in the position value to the offset, and you see already it is sitting on the curve. And if I put this to factor value and say 0, and now if I change this factor, observe how it is following the curve geometry. Okay, now this is changing the color because of the strength we have connected to this. Let's disconnect that, and I do this again. See, it's gradually following the curve to the end, because the factor value, if you take the spline parameter node, you can see this curve's factor value is coming gradually increasing from 0 to 1 at the last point. What happens if I put a length value? Length value also same, but in this case it doesn't stop at 1. Okay, it starts 0 and then gradually goes till the end of the length. We see here I'm changing the length further, but it doesn't change because there is no data for this particular length on the spiral curve. Okay, but if I change the number of rotations, okay, you see now it has some more length left, then it will come. See, get it? It's this, reduce this to 2. That means the total length may be somewhere, yeah, around 18, 19. Yeah, after 19 there is nothing. Okay, so this is on the curve geometry having the data fed into the mesh geometry. The position of the mesh geometry is affected based on the value here. Okay, so this is all we have. Value I have told. We have one more thing that's called all curves. All curves is involved when you have more than one curve geometry in the input. That means whatever sample curve input you have, if it contains more than one, then this is useful. So for that reason, let's bring in one more curve. Let's duplicate this and inverse it. Okay, let's bring in join geometry. and connect this. And so this output is going here. Instead of that, take this and disconnect this. To see this clearly, let's bring in the transform geometry node so that we see it clearly in the z-axis. Okay, so now I have two curves, or maybe I'll stop the reverse so that you have the continuous rotation. Yeah, like this. Okay, so it is ending up here and then starting from here. Now if you see and do the same thing, make sure you have connected the both the geometries to the joint geometry, and that is what fed into the calculations. Now if I change here, observe, I'll go for the factor. If you see, it stops at 1 and that stops at the first curve we have. It doesn't take the second one. Now if I change the order of this, what if I connect this one first and then this one second? What happens then? You can see the cone has already moved to the second curve. It means in this order, this is the first one. So this is the first one connected here, then second one here. If I change it again, then you can see this is the first curve, this is the second curve. Just by changing the order, okay, if I just move this up in the order, then you see this one is changed from here to here. That means this is the first curve, this is the second curve. And we have not selected the all curves. So the factor will start from 0 to 1 on the first curve only. So this first curve is decided based on this order. So there is a nuance to this in the joint geometry. You have to take note of it. Now if I click all curves, now you see the factor value is 1, but it is at here because you see. So since it is this is the first one, this is the second one. Let's fix that order first, so that we don't have any confusion. Okay, now if you change the factor value to 0, from gradually from 0 to 1, it will follow the curve nice and good. See, at this point it has jumped from here to here and then continues to the further curve options. Same thing for the length. In this case, length takes the accumulated length value, so it will take some more value to reach the top. So this is the use of all curves. Whenever you have more than one curve, you can use the all curves to calculate all the things together. And if you disconnect the visibility of the curve, then you have a nice, animation on an object following the curve. Any curve you have. See? So for the visibility purpose, I have added that. So that's about the sample curve node. If you find this video useful, please like it, share it with your friends. If you want me to cover any specific topics in Blender geometry nodes or any questions on this topic, please let me know in the comment section. Please subscribe to my channel. I will see you in another cool video. Thank you. Bye.